third part of this session where I will be telling you about how to create cloud resources using Terraform. So, what is Terraform? Terraform is a popular infrastructure as a code tool that allow developers to define and provision infrastructure as a code, which enables them to automate the process of creating and managing the cloud resource. So the next question you will be having is like, how does Terraform work basically? So Terraform creates and manages resources on cloud platforms and other services through their application programming interface. Providers enable Terraform to work with virtually any platform or service with an accessible API. So now you will think like how the Terraform works basically. So there are 3 to 4 parts. So first you need a defined resources. Right, where you define resources which may be across multiple cloud providers and services. For example, you might create a configuration to deploy an application on virtual machines in virtual private cloud with security groups and load balancer. Or maybe you're creating an EC2 instance or or the ELB, KNB. So you have to first define all the resources using the YAML file. Then the second is plan. Terraform creates an execution plan describing the infrastructure. It will create, update, or destroy based on the existing infrastructure and your configuration. And lastly, it is the apply. On approval, when everything is okay, then Terraform performs the proposed operation in the correct order, respecting any resource dependency. So there are various advantages of using Terraform. So the first one is version control. So Terraform code can be stored in version control systems like Git, which allows you to track changes and collaborate with other team members. Then the second is reusability. So Terraform code can be organized into reusable modules, which makes it easier to share and reuse infrastructure across different projects and teams. The third is flexibility. So Terraform supports multiple cloud providers such as Azure, AWS, GCP, as well as on-premises and other infrastructure, making it a versatile tool for managing infrastructure. The fourth is automation. Terraform allows you to automate the process of creating and managing infrastructure, which can improve the efficiency and speed of development process. The fifth one is the dry run. So Terraform has dry run feature, which allows you to preview the changes that will be made to the infrastructure before applying them. Then then is state management. So Terraform keeps track of the state of the infrastructure changes and it manages, which allows it to make incremental changes to the infrastructure and defect drift from the desired state. And the last is cost manager. So it allows you to define the resources you need and Terraform and the respective costs. This will help you to estimate the cost. So let's quickly go into the pipeline and discuss about step-by-step explanation of Terraform files for the Spring Boot application which we are deploying in the project. So if I go in this DevOps pipeline, DevOps blog, GitHub repository. So here you can see modules folder and the Terraform code folder. So in the modules folder, all the resources are present, all the resource files are present. We have defined various resources such as EC2 instance, ECR, IAM, instance profile, security group. The folder contains Terraform files for output and variables that are used to manage these resources. While if I go to the Terraform blog quickly, here you can see there are many files which are present. So the main file is main.tf file, where we are defining the module of ECR, EC2, IAM, and IAM instance profile. So what is module is like? A module is a collection of related resources that are organized together to perform a specific task or function. And it allows you to reuse these and share code across multiple projects, making it easier to manage and maintain your Terraform code base. So here you can see that all the resource block that we have added, it is called into this main.tf file. And this backend.ts, so this Terraform file contains the information like where we are going to store our state data files. So here you can see that the backend is an S3 bucket, while the provider.ts, which we have added, is defines AWS as a provider. So here you can also see the region where we are deploying our resources, which is US East 1, and even the version and the source file. Then variables.tf file. So this is a file in Terraform that is used to define all the variables that we have added in a main.tf or the main.tf file that can be used in the Terraform configuration file basically. And if I go to the terraform.tvards file, so this is used to store values for variables in the Terraform. So whatever values that we have assigned in the variables.tf, those values, configuration file values we are adding here. All the values are present. We can every time configure and customize the behavior of the Terraform variables file here and assigned here. Then, so let's check. So let's check the modules folder, and we will check the module folder by folder. So let's go to the security group first. So this here you can see that we are creating a simple security group in AWS. Here we are passing the name, description, and the CIDR block, even the tags, and environment variable. Using the variables file, we are defining the variables here, and we are adding 3 ingress rules here with port 228082 and 9000. So 22 for SSH. The second is for 8082 for JFrog and 9000 for Sonar Field. And while egress, we are giving the whole access for the egress part. And these are the variables that we have defined by using var.name. If I go to the variables files quickly, so here you can see all the variables file that we have used, all the variables that we have defined for security group, and the output section. So this is outputting the, it is sending, printing the ID of the security group which is getting created. So we can use this output in our EC2 instance or somewhere relevant. So let's go to the IAM and go to the im.tf file. Here we can see that we are creating an IAM role, where we are passing and even the policy which should be assigned to this role. And this is the role for in EC2 instance. And here we are giving all the permission of ECR full access and S3 full access. So we are assigning this policy to this role, which basically will be added into an EC2 instance. In output section, you can see that it is also, you are getting this output basically for the role. Then if I go to the IAM instance profile, here you can see that what we are generating we are passing the name and the IAM role, which will be assigning this role created above. Here we are creating the IAM instance role, which will be for the EC2 instance. Then we have the EC2 instance, where we will be adding all these things. In the EC2 instance, what we are doing is like, we are passing the instance type, security ID, instance profile name, and the environment variables. So Terraform is getting the AMI ID of the Ubuntu machine using the data resources, where we have defined that we have taken the most recent version of the Ubuntu machine, which is 22.0.4, and the root block is the root block of EC2 instance is 30 GB. So this is the memory storage that we are using, and it is encrypted. And so this is the whole thing. And here we are actually using the EC2 instance, creating an EC2 instance. By the data block, we are assigning the AMI ID, then instance ID, then we are assigning the keeper that is already created. The security groups are added, and the instance profiles are added. Let's go to the ECR block. So here we are creating an ECR repository where we can store all the images which will be done in the later part of the session. So here we are adding the name, image tag, immutability, whether to scan or not. And then we have added also the encryption part. So this is the whole structure of the repository and the directories which we are adding. So the whole Terraform part is uh, distributed in modules part and the Terraform code. So the modules part is containing all the resources, and the Terraform code is basically adding all the modules and combining all the modules which are present in this part. So this is all for the third part of the session. Thank you, everyone.